These will be some basic things that anyone could do to test the validity of the flat Earth hypothesis. These are so mind-numbingly obvious that the fact that you don't do them is an immediate indicator of your complete lack of intellectual integrity. Let's get started and you'll see what I mean. Number 1. Here's the flat Earth map that you all seem to agree upon. Anyone with half a brain can immediately tell that this does not correlate with reality.
I find that flat maps correlate quite well with reality. Globes, not so much. Google Earth, for example, when you zoom into the view where you can actually see real things, not computer-generated shapes and things like that, it's flat. When you zoom to a level where you can measure from point A to point B, it's flat. If you piece those together, the corners match up. If you take any aerial photographs at all over the world, and you piece them together, splice them together to fit perfectly, if they fit perfectly, the photographs are flat, and the corners match up perfectly, and you get a map, much like what you have shown. The fact that circumnavigating goes in a circle, east to west, and rarely or never in a verifiable way is even never happens in a verifiable way, and rarely is ever claimed to happen north-south. There are a lot of really startling clues that tell you, like, how many people do you know who have been around the world did it east-west, like a circle, like what we are saying? I know hundreds of people. Not one of them has ever done the north-south way around, not over the southern part. It's very much like an outer ring. And when you splice together the photos, yeah, it more closely matches that.
But for those with an even smaller fraction, let's do a few things to prove it. For example, make a scale. You know, a scale? It's that thing on maps that tells you how far away things are from each other.
Now, this part, the condescension to think that we are at a level that we haven't even gotten through the formative years of education, like grade school, is very disingenuous, I think. And it also is insulting, it's belittling. I think it would demand an apology. It also skirts, well, besides belittling your opponent and doing that type of stuff, you're creating a narrative in your own mind where you don't think that we have the intellectual capability to even discuss these basic things, when in fact these types of things we got through in such early stages of research, like seconds, that the distance behind you are in discovery is astounding. It really is astounding. But let's muddle through this. It's the belittling stuff, though, I don't mind it at all, because it's so comical. You'll laugh at it. If you come around, you'll laugh at yourself for it. I hope you do.
Look at this map. There's a scale. You can pick two cities and determine the approximate distance between them. Then you can drive your car from one to another and verify that it is the correct distance.
I agree. Would you agree that that map is flat? Oh, shoot, you didn't think about that.
Now back to your little map. Where's the scale here? Why do you never include one? Is it because it's impossible? Yes, that is exactly why. And if you disagree, here's your challenge. Pick some distance on this map, a centimeter, an inch, whatever. Tell me the distance it corresponds to in reality. Then pick some cities and use your scale to estimate the distances between them. Pick two on the same continent. Pick two on different continents. Use it to tell me how wide this inappropriately enormous ocean is. Use it to tell me literally anything about the distances between literally anything.
Sure. Let's take the Google Earth photos, and these are aerial photos, not from a satellite. They're high altitude flight photographs made from the air, and splice them together, and we can do all of those things. Now, where would it be a problem? Where would it really show that it's matching our map versus yours? In the northern latitudes, not so much. Okay? In the southern latitudes, it gets to a point where it would start to show all of these things. Now, if I compare these photographs from Google Earth from the northern latitudes to the southern latitudes, do I encounter like CGI spawn in the northern latitudes? No, I don't. That's verifiable. But in the southern latitudes, where the scale issue would become more apparent, you get to a point where the oceans, they can't make up for the stretching. Okay? We'll talk about stretching in a minute. Then, when it becomes a real problem like that, the verifiability of the comparison between the southern latitudes and the northern latitudes becomes more divergent. And the southern latitude areas, when compared, are geographic spawn, computer CGI, animated, made up terrain spawn. Whereas in the north, there's actual verifiable stuff like you mentioned. So, okay, challenge met.
When you can't do it and your numbers do not correlate with reality in the slightest, recall that this map does it just fine, and then admit that your map is stupid.
Well, that map doesn't do it just fine, because that map, you're talking about correlating with reality. That map does match up with the distances because it's flat. That's why it works. If it were curved, it wouldn't work so well. And you can say, well, it matches with the lines and everything like that. But again, how could that work if it's actually curved in reality? So the reality doesn't match the map where you do the lines and everything works out? Ooh, that's a problem, isn't it? Think about it. Now you go to a larger scale, and the same principle applies. The thing about it is, you wonder, well, what about Google Earth? You use this Google Earth, and you can zoom out, and it's a globe. Do you notice, though, when you zoom in, it transitions. And when it transitions into flat, I know the geometry makes it seem flat. But if the disparity is in the model, in the problem of the globe model being artificial, being different from reality, then there are experiments we can do to verify why and how much. If isn't a question for me, it's a question for you. The if part is simple, and it's in one of your later challenges, so it will support this point. But I just wanted to follow up with what I mentioned about the curve, because the map that you showed as an example, not only did it have several different scales, like Alaska being shrunk down, and it's very convenient, but if you would blow up Alaska, blow up Hawaii, put them relatively where they need to go on that map, that flat map, Then you have stretching. You have different problems of scale that rarely get addressed. So if it works on the flat map, then how could it be curved?
Your complete inability to make any kind of remotely legitimate map single-handedly proves the Earth isn't flat. But let's continue just for fun. Number 2, as we all know, the existence of Antarctica poses a huge problem for you. When it is summer in the northern hemisphere, you love to pretend that the sun moves inwards to this tropic, making the days longer here and shorter in the southern hemisphere. And then when it's winter in the north, you like to put the sun at the other tropic, which you think gives you the shorter days up north that you want, but in the south, it's total chaos. You have the sun tracing this enormous trajectory, which would leave everything out here in darkness for most of the day, when in reality, there are long periods of time in Antarctica where the sun never sets.
I hear you. I understand what you're saying. I haven't been there. I don't know if you have. But it makes a big difference to actually make the observations versus accepting what you're told.
Since your dinky little sun can never illuminate this entire fantasy ice wall at once, this completely obliterates your model, which is why you resort to conspiracy. You simply deny that this midnight sun ever occurs, while claiming that no one can go to Antarctica to verify it for themselves.
Whoa, slow down there, champ. Okay, what you showed with the sun going around and it illuminates in the southern latitudes on the outside, that can happen several different ways, and it's demonstrable by experiment. And one of them is the reflection. So you know how fiber optics work. When you have a shallow angle beam on a glossy surface, a reflective surface, the reflectivity of the light increases in, well, not even a linear scale. I think it is logarithmic with very, very high reflectivity. That's how fiber optics work over such large distances. And that reflectivity of the light happens along a smooth, curved surface. Now, we do speak of a dome. Oh my gosh, it's a word that sets people off. Well, though I haven't been to it and I can't see it or touch it myself in person, the existence of such of a thing would explain several answers to problems that are mentioned here, but it's not a problem when it's an observation. So yes, we observe that there is light in the southern latitudes. Of all these types of comparisons between the North Pole and the South Pole, there are way more inexplicable differences, or differences that would be not explained by the heliocentric model very well, than there are similarities. But since you spoke of the similarity, and this is your set of challenges, that is the response that I have. That's one of the ways, is the reflectivity of it. And there are other explanations. I don't like them as much, but they are facts. I have not been to the sun, and I don't know what it is exactly. I know what I've been taught. I know what I've been told. And the things that we've been taught and told about the sun have been incorrect in the past. For example, the distance to the sun. If you look back and see what Isaac Newton thought, it's not the same thing as what Einstein thought or what Copernicus thought. They're all different numbers, and they're radically different. They're wildly different. And we're taught now that it's approximately 93 million miles. It changes, we are told, because of the obliquity of the ecliptic. Well, we don't know that, though, do we? We haven't stretched out measuring tape And I don't think that we are going to anytime soon. So it's merely academic. And my point is that if we don't even know how far away it is and we don't know the nature of it, then we have some issues to deal with that are fundamental to answer this question. But it's a response, and I think it's intellectual. I think it is more interesting than reading Wikipedia and restating what that says. Because if you just want to believe that all the time, then what are you making videos for? I mean, what is your pursuit? What is the scientific experimental discovery of what is going on there? It's not in my opinion. Sorry, I don't find it as interesting. It's not for me, but okay. But let's move on.
Because the government NASA Jew penguins will kill you. Well, apart from all the commercial cruises...
What? What? Come on. You are equating... Okay, what you're referring to is Antarctica and the treaty that makes it pretty much impossible for you or me or anybody as a private citizen to freely explore the continent. And merely stating that as a fact, it's a fact. Like, yes, you can go to Antarctica, but you can go to Pyongyang, North Korea. Can you freely explore the camps, for example, that we hear about? I suppose those don't exist. Or, you know what I mean? Like, okay, no, we agree, those exist, right? Well, we haven't been there. I haven't thought about it personally. That issue I haven't thought about. It makes it a little bit more curious when you haven't visited what's really going on there. Would you be satisfied with what Kim Jong-un says about them, or the state media says about them, when you can't go there? Now, if you're not satisfied about that, I would say it's similar, but then why are you claiming anti-Semitism? There's some kind of a defensive, anti-intellectual stance about this whole thing that makes you feel desperate to have to belittle your opponent and cast all these aspersions upon those who disagree with you. I find it unbecoming.
Civilians can even apply for jobs there, so you totally could go see it for yourself.
I'm confused. Are you talking about the 24-hour sun? Yeah, the days are longer and all that, but I've already covered the reflection thing. I don't think that the sunset and sunrise profile matches between the corresponding latitudes, like how nothing really matches between the corresponding latitudes north and south. How many people live in the Arctic Circle? Millions. I think it's like 4 million. How many people live south of the Antarctic Circle? 4 million? No. 1 million? No. 100,000? No. 10,000? No. 1,000 people? No. Look at trees. I think the answer to that, it gets a little... I think nobody does, but I'm talking about year-round residents. But let's talk about trees. How many trees are north of the Antarctic Circle? Millions. How many trees grow south of the Antarctic Circle? Well, not many, not any. Maybe inside of a building, if the buildings really are located where they say they are, because I look at Google Earth and I look at the South Pole and I don't see the South Pole station where it's supposed to be. Is that a problem for you? It's a problem for me. But again, I don't just accept, well, they told me it's there, so it's there. And Kim Jong-un told me that the internment camps for re-education are there, and the people are there very happy. I mean, they want to be there, and, when do you have some skepticism? Isn't that what science is? I'm skeptical about the Amundsen Scott South Pole Station when I look at the Google Earth. You guys listening who are like, maybe you're like, this guy doesn't seem so stupid. He doesn't seem like he has a less than third grade education. Maybe he's not completely insane. I am completely insane, but I want to be. The alternative is just boring. But regardless of my own personal preferences of levels of sanity with respect to fun things, it's a serious problem when you look and it's not like they say. Like, why, with all these satellites, with airplanes, he's take an aerial photo of it and paste it on there. It seems to be what they did with the rest of Google Earth, but it's not a problem.
But you don't really have to go all the way to Antarctica. Just go to the tip of South America, like this town, where people live. Or don't even go there. Just look up times of sunrise and sunset on the internet. In mid-December, sunrise is earlier than 5 a.m., and sunset is later than 10 p.m. Now take your little model for the seasons and make it show night and day. Then try and make the night and day portions match up with these sunrise and sunset times. Demonstrate the light from the sun illuminating this location for more than 70% of its trajectory. And as you do that, make sure that it does not illuminate Point Barrow, Alaska whatsoever during its entire trajectory, as that town has endless night during this time of the year. That's right, lots of sun over here and zero sun over here. Good luck. If you decide to even try, observe that the light patterns become so nonsensical that not even the most meth-fueled creatives amongst you could vomit enough magnetism jargon to justify it.
Well, okay. First of all, if somebody is belittled in the right, does that make it worse for you? I mean, you should think about that. Let's see. You challenged about how could it illuminate like that. Well, if you consider the fact that the atmosphere isn't perfectly clear, if the atmosphere is somewhat translucent, then it's pretty easy to understand that a point source of light with a reflective bowl or ring or dome around and above it that reflects the light, that could conceivably illuminate around the outside, and maybe then there's a solution. Now, could that be done by experiment? Yes. Can a floating ball in space that spins, it's spinning like a top, they say, but it's tilted. The axis of rotation does not match the axis of revolution. The axis of revolution would be up and down, because there is an up and down even in space. In our solar system, there's an up and down. Why is that? That's another problem for you, but not. Okay, so you have this tilted axis of rotation and this revolution around another axis. Demonstrate that in experiment, please. I want to see it. I want to see how that works. Now, that would explain the seasons by the heliocentric model somewhat. The obliquity of the ecliptic is a problem for you. But these aren't my challenges for you, because I've answered these. I just go on my own. That's what we do. The Globebusters, the so-called flat earthers. You can make condescending tones and things like that, but really we are autodidactic. We don't toss out, quote, all of science. We have a lot invested in that, but it's a sunk cost. And so the marginal benefit of sticking with something that has been proven to be unreliable does not outweigh the marginal gain. We don't toss out any of science, in my view. What is observable, repeatable, and reproducible, that is what we cling to. What is told us by fiat, with a wave of the hand, imagine this heliocentric model. This is how it is. It's something drilled into us from a very young age, and there are many, many problems with it. And after a while, you just have to go on your own. Yeah, I don't need to say more.
If you can't make your model show the seasons and night and day at the same time, as I pointed out that you can't almost a year ago, then seriously consider shutting up forever.
Well, you would love that, I guess, but I take issue with a couple things. I saw that map you had up there. That's Rob Skiba's map. Rob Skiba is a decent fellow. He was on Globebusters with me in one episode, and I rather like the guy. I take issue with you inferring that he's a meth addict. And I ask you this: if a meth addict came off the street and said something that were true, would it be not true because you think that you're better than them because of that? Now, I know that you're being facetious and everything, but the attitude really is harming the tone of of intellectual discourse. I'm thinking of it as political because of why you have that tone. It's not science. It's politics. And politics suck. Come on. You really want to do that? Come on. Investigate.
Number 3, here's an idea. What if you were to actually make a prediction with your model? Like any prediction. Those things that you have to do in science for it to be science. Pick any celestial object, a planet, a comet, a star. Now pick any time in the future, and using only the flat Earth model and nothing else, tell me where it will be at that time.
Well, sure. The astrolabe kind of looks like a flat Earth. It's a flat disk. It is an analog computer, one of the best. It has between 500 and 1,000 functions, maybe more, things that it can do. It's very accurate. It's been around for 1,000 years, I think, maybe more, thousands of years. But in the most commonly found form, it's, I'd say, about 600 years old. So it predates the globe. The Erdapfel, that thing? That's your model, the first one. And when it was made in 1492, it was incorrect. It shows the continent of, Europe and part of Africa and Asia out of proportion. It's not to scale. Now, the reason I say that is we're told that Eratosthenes found and calculated with great accuracy the circumference of the Earth. Well, it was the path of the sun around the equator found to be approximately 40,000 kilometers. It was very, very close. And that path, I agree, is pretty close to that based on what we know. And that would denote a certain scale and distance proportion of the land masses that were verifiable in 1492. I don't think that the Erdapfel approximates them very close at all. I think it's very poor. And I think as a predictor, as a navigational tool, it would have been pretty much worthless compared to an astrolabe, very much worthless. An astrolabe, a sextant, very accurate. Surveying tools, they function based on a flat plane. Water level tools, the old-time surveying method with water pipes and leveling that way, based on air pressure, visually matches a flat plane. The largest scale model of a working celestial environment we know to be a planetarium. And every planetarium I've ever seen has a flat floor and a domed ceiling and roof, and you look at the stars and they go around and rotate the firmament. And that's a very nice working model that accurately predicts what we see in our vision dome around us, because we can't see forever. We look through air, and if it's flat, when you're in an airplane over Missouri, you can't see France because there is atmospheric occlusion. So I think that might be something that you need to know, but we'll see if you've gathered that already. But there's your answer. I mean, the astrolabe and planetariums predict very well, and they are our model. Just like everything about observational, that is what we cling to. That is our model. And so it looks flat.
If you can't do this, and I know you can't, consider admitting that your model is absolutely irrelevant. People who actually understand the geometry of the Earth and the solar system can predict a solar eclipse, specifying the start and end time down to the second and tracing its precise path down to the square mile. Doing that even a single time means the model used to make the prediction has been undeniably verified, and it's done every single time. Anyone who doesn't see the importance of that has no clue how science works.
Well, what you're talking about is pattern recognition, and I think that you know that finding a pattern is not necessarily science. It's pattern recognition. It's predictive modeling. Let me give you an example. You can have two different computer models that both predict the same outcome with the same inputs, but they use different functions and different formulas. It's just like with math. You can have x equal a certain number and y equal a certain number and plug them into different functions or formulas and solve for a third variable and arrive at the same number. The functions are different, and if you change x and y, you get different results. If you change the third variable, you may achieve different results. And so the predictive modeling does not prove that the model is correct merely by making predictions. It only proves that so far, based on the variables given, that it works for predicting it. The model itself doesn't explain everything. the model itself is a construction of something symbolic based on the observations. So, of the different models that work, I think of the astrolabe, which is a flat disk. Now, again, I'm not saying that that proves it, but I'm illustrating the thinking here. And again, if you can look at the age of the astrolabe, we were told that people back then didn't know about the globe or didn't believe the globe. So how did they make the astrolabe? And why isn't there a model with balls moving around, and that predicts the eclipses with lights at a distance and all this, casting the shadows? And we see that in CGI, but that's not a predictive model. You can't take those CGI creations and predict anything with it. They're illustrative. And by the way, Rob Skiba's diagram from earlier had a disclaimer on the side that it was an illustrative depiction. So, you can have it both ways.
Number 4, after I demolished essentially all of your favorite talking points in my previous videos, you all now cling primarily to the classic "I shouldn't see this thing" argument. You love this one because you can lie about heights and distances, do incorrect math, and in general act incredulous without having to actually do any science.
Whoa, easy there. Whoa. Okay, now we're talking about this issue, which is your biggest problem, actually, that we can see things that we shouldn't be able to see if the horizon were as it should be if the Earth were a globe with a circumference of 40,000 kilometers, a sphere. We do the math. And if you want to talk about the visibility of the approximations that are made, that's nitpicking when the plus or minus several feet or several meters isn't going to make up the difference for you when we can see a mountain 100 miles away from a relatively low altitude. That is a huge problem for you. And what we hear when we bring this up is that the landscape must be such by elevation that the hump of the curvature of the Earth is not there because the land elevation, it must be going downhill and back uphill, so that's why it looks flat, but the Earth isn't flat. So therefore we do it over water a lot of times, but we've done both, and the results are astounding. They are observable. They are observations. They are mathematical because we mathematically predict what we should be able to see and how much of it should be covered up. There is atmospheric occlusion that covers up some of it, the vanishing point limits of resolution and visibility. But that's minor when we can see entire oil platforms and things like that that should be mostly hidden from view. And when I mean entire, even though we can't see the very bottom of it because of temperature changes and things like that, we can see the ocean behind it all the way up to another oil platform. And we can see all the way down that. And then the horizon is behind that. And the horizon should actually be between us and the first oil platform. That's major. That is very major. So I don't appreciate these accusations when, if you look at the facts, you're just talking, it's not based on the actual things that we're talking about. So this challenge has been met. It's really a challenge for you, but if you want to challenge us on our best evidence, there's no best evidence. Any one thing demolishes the heliocentric model. It's been demolished so many times. Why are you clinging to this fad?
Well, every time you whine about this, the objects are always suspiciously close, such that you can fudge the numbers, and they're always over water, so you can lie about refractive effects to people who have no idea how refraction works. So try this one on for size. Show me a picture of something over land that's 1,000 miles away. May I suggest the middle of the country where there's not much in the way?
I can't believe this. I think you're okay. I won't say anything. I don't want to say anything about someone's intelligence. I guess I have to say you can't see through air forever. It's like a fluid. It's like when you're on the ocean and you look down and you can't see the bottom when it's 800 feet down. Is that confusing? Or do you understand why you can't see that bottom? Air is the same way, Dave. Do you really think it's possible to see 1,000 miles through lower atmosphere? I mean, I shouldn't have to explain this. Okay, let's move on. Well, what was the other insult? Do it in the middle of the country so there's nothing in the way. You mean at ground level, or what are you talking about? I mean, there would be trees and houses and windmills, and I'm thinking of things that I've seen at great distances. It's just look at it the data. Get a camera and check it out. It's amazing.
It's a straight shot after all, so what's the problem? Use a telescope. Pull Las Vegas into focus from Dallas, Texas. Isn't that where you have your little meeting? Maybe you should try doing something productive rather than blindly perpetuating the dumbest hoax on the internet.
Oh boy, this is good. Okay, just take a look at this.
Number 5, speaking of things that are far away, you all love whipping out your Nikons so much that I wouldn't be surprised if a Nikon executive dreamt up the entire flat earth hoax as a viral marketing campaign.
What you just said, that's like a crazy conspiracy theory. The irony, oh my gosh.
You take a boat that's far away, pull it back into focus, and then marvel at your own brilliance for figuring out how to operate a camera. Well, try this one then. Stay on the boat. Don't cut away. Stay on it until it disappears. How will it disappear? Bottom up, just like everything else. I wonder why you've never put that on YouTube.
Are you suggesting that when that would happen, that it's because of the horizon and the curvature of the Earth, and not the same reason it happened when we didn't zoom in as much? Well, we do put it on the internet, and then we zoom in more, and there it is again. So when is it the horizon? Do you get it? And it's, when you zoom in fully, and then it disappears from view, that's the horizon. That's the curve of the Earth. Well, yeah, I guess it could be, but you know what? We do these things regularly, and what we have found is the distance at which that would occur has to do with the atmospheric conditions and not the geometry of the land or the sea at that time. So, when that distance is changing day to day, is the circumference of the Earth changing day to day? Is the ocean undulating in a large curve? Is the horizon moving?
Number 6, the most hilarious thing about Flat Earth is that the most mundane everyday observations make absolutely no sense in your model. Like a sunset. A small sun above a flat Earth would simply recede high in the sky and get smaller and smaller until it fades away. It absolutely would not retain the same angular size and set below the horizon.
Well, wait a minute. Why would it fade away? If we can see thousands of miles with perfect clarity, why would it fade away? Well, okay. Besides that inconsistency, let's address this. The angular size does change slightly. Now, the reason that it doesn't change could be this. If the sun is so far away, but yet so bright, that it is not the actual sun you're looking at, but it is the light from the sun entering the local atmosphere within your field of vision, the angular size would remain about the same. If the angular size doesn't change because the point source of light is outside of your personal local atmospheric visual range, then when the point source of light recedes into the vanishing point beyond the scope of resolution that you can detect, well, that combined with occlusion, that's the translucence of air, you would, in fact, experience exactly what we observe. So that's the answer.
It stays the same size because it's unbelievably far away, and it sets below the horizon because the Earth is a sphere that is turning. Even a toddler can understand this. It's so blatantly obvious that you have to resort to your typical ad hoc antics, talking about refractive effects that defy all logic and somehow magically apply to the sun but nothing else.
Well, if the premise is that you're looking at the actual sun, then you're saying that that source, that light source, is within your personal field of vision. Well, I think you would agree that at 93 million miles, it's not. So if you're looking at just the light striking the air and illuminating the air, which makes the brightness of the object that you're seeing, what we call the sun, that bright light in the sky, then obviously there is going to be some refraction. There's also going to be some magnification. And with the angle of incidence, you're going to have, of course, those two effects plus some diffraction and some diffusion. And all of that's taken into account. And still, I think, yeah.
Or even better, some of you talk about a dome with the sun on the other side that produces some bizarre optical effect.
Okay, so now we're talking about grade school things. We're talking about listening. There are two domes. One is your personal field of vision. You can't see forever. You can only see so far through any amount of, through air or through a liquid. In any case, you can only see so far. And so it's actually a sphere of vision. It has nothing to do with the geometry of the Earth. The other dome is the one you showed, which is much larger than your field of vision. Okay? And you're wrong about something else. I'm sorry to say, but the sun is within the dome that you just showed. That dome that covers the Earth like a tent. It may not be shaped like you have shown. That's an animation. We're talking about a graven image, if you want to speak about it in terms of Mosaic law, of the Ten Commandments, thou shalt not make unto thyself any graven image. Now, that's talking about idols like golden animals that are worshipped, but the globe is worshipped, not by me. So, okay, the sun would be inside that dome that you showed, okay? But your personal field of vision, that dome, would be beneath the point source of light we call the sun, okay? Is that clear? I'm trying to educate you. I don't know if you'll listen, though, because that seems to be a problem. I'm going to have to mark you with a Not satisfactory, unsatisfactory.
Apart from the sheer absurdity of this magical dome that no one has ever seen or touched,
Well, okay, the Voyager is something I've never seen or touched at 13.8 billion miles away. Okay, so what is that? Is that a thing now that it's magical and ridiculous if you can't see it or touch it? I mean, the TRAPPIST system. I mean, okay, let's talk about that. Let's talk about the Mars rover. Wait, no, I can see it and touch it. I haven't been to Devon Island, Canada, but I've seen photographs of it. I've seen that on Google Earth. I haven't seen the Amundsen Scott South Pole Station, but I've seen I've seen the Mars rover.
it creates big problems for you because you also claim that the sun and moon perform other kinds of magic to push the air and water around, to get tides and storms and what have you.
Now you're all over the place. Now wait a minute. Don't you also say that the sun and the moon cause tides and all that? I mean, well, also wait a minute. No, we don't say that the moon causes tides by gravity, at least. And one of the reasons is we don't see tides on the Great Lakes, for example. Now that's a problem for you. But again, these aren't my challenges. We're probably never going to get to that because that's been tried before. I mean, we're not even interested because that would be an exercise that we've already done. That's what we did when I tried to debunk flat Earth. I did these things and I was not able to debunk them. I found only problems with the heliocentric model 3 years ago. That's when I switched. I'm not going back. That'd be like that's insane. I mean, I've only found, in the real research I've done, I've only found problems with the heliocentric model. And whenever, well, you can be uncomfortable with it, you can be upset about it, you can go, I did go through several months of refusal to accept it fully. It was just an interesting, like a curious thing that I was laughing about. But the intellectual honesty remained with me, even if I lost conversation partners and things like that, because the conclusions that are undeniable based on the facts are what they are. And it's a lot of people, through various means, are unwilling to even entertain the thought, much less investigate, much less answer. But I have no problem answering questions, and sometimes I don't know. So if you try to do this thing where you say, explain the TRAPPIST system then. Well, the TRAPPIST system, you guys made that up. I don't know about that. I mean, just explain why the Sith, there's two and there are always two. And I don't know. I mean, I didn't make that up. So, I mean, I can probably come up with something. I'm creative that way. But we're talking about science. We're not talking about, storytelling. Well, what is science? It seems to be a lot of CGI in storytelling, if you ask me.
That would require that it is inside the dome. So which is it? Is the sun outside of the magical non-existent dome so you can pretend to get the sunset? Or is it inside the magical non-existent dome?
Well, with the false dichotomy you gave me, I can't really answer that because you're telling me it's magical non-existent. So am I going to sign up? Okay, yeah, I believe in what you said. I believe in a magical non-existent. I mean, if I were like that, I would be a NASA fan because somebody told me that there's a Voyager 13.8 billion miles away with a 60-watt transmitter sending signals and receiving signals, so they remote started it after 37 years to retask it so that it could pick up signals. Well, how did it get the signal for the liquid propelled rockets to fire up after 37 years to retask, to reorient back in the slightest of angles in order to shoot the beam, the 60-watt beam that only the NASA Deep Space Network, the DSN, can pick up? Okay. But if you want to insult me, I mean, be careful.
So you can pretend to get the tides. It can't be both. Or if you bail on the dome and say it's just water.
Well, to answer the previous question, I would have to reject the phrasing of it, and I would say it's inside that dome that you showed, not the personal visual dome. That's a different one, okay? But if there is a dome over the entire Earth, which I believe there is, okay, is it shaped like that? Is that scaled properly? Is that something that we could ever see? I don't know. But I can say that I don't know. So that's for that. Now, what is this next one?
How do all those water molecules that make up around 1% of the atmosphere produce 1,000 times greater refractive effect than actual liquid water?
Oh, he's talking about the sunset and how, okay, we've already moved on from that. So, yeah, I've already explained that.
How does the appearance of a sunset never vary at all, whether it's dry or humid or raining?
Well, it does. It does vary. When it's raining, sometimes you can't even see the sun. So the sunset does vary. It varies between the northern and southern hemisphere, given equal latitudes and longitudes, equivalencies. Almost nothing perfectly matches. Now, the numbers will match, but what is a sunset? What is a sunrise? Is it something you can pinpoint? No, it varies based on the atmosphere. Any weatherman who's been through his meteorological training, basic meteorology will tell you that. I mean, yeah, it varies. Yeah, it does.
Why does nothing else but the sun behave that way? Show me a projectile or a plane going below the horizon as it recedes.
Dude, we've tried. You can't. It's not. That's the horizon isn't like a curve like that. It's a vanishing point. It's a line that goes across perfectly straight and flat. I mean, come on. Listen.
Or show me this dome and explain the phenomena with more than buzzwords. Do something to explain a sunset. Do anything besides making idiotic videos with action movie soundtracks that contradict middle school level science.
Okay. Done.
Number 7. What the hell is a lunar eclipse to you? Seriously, explain anything about a lunar eclipse. The things you say about solar eclipses are stupid enough, but at least you say something. A lunar eclipse happens when the Earth gets between the sun and the moon. That's right.
Well, you're asking me to explain, but what are you explaining? You're just repeating what you read or what you've been told. Well, I've seen a lot of explanations. If I had to explain it, I definitely would not use the heliocentric model because that has some problems. The aforementioned ones, of course, hundreds of others, thousands, and the lunar eclipse, well, the shape of the shadow, the selenium is a problem for the heliocentric model. So how could I explain the selenium? Well, using the explanations from a different culture and a different time, because I'm open-minded, and there are ancient texts that talk about Rahu and Ketu, and these have been observed to some extent in various photographs from high-altitude balloons during the eclipse. So you're talking about the lunar eclipse. Well, okay. Yeah, I think it could be these objects up in the vicinity of them.
In between. These two objects are not perpetually above a flat plane, and you know it, which is why you're totally silent on lunar eclipses. And if you're going to propose that some other object besides the Earth is what obscures the moon, good luck trying to demonstrate its existence.
Well, the demonstration of its existence is the observations we've made. We don't know what is occluding it, but we know it's not the Earth. It's not a spherical Earth getting in the way, because you have the Selin-Helion effect. I mean, that's an observation. Now, the mainstream explanation for the Selin-Helion is refraction. Now, based on what you said earlier about refraction, I don't know if you're going to go there, but okay, so I've said that. So that's been done.
Number 8. Speaking of the sun and moon being small and close to the Earth, what is stopping you from strapping a camera to a weather balloon and sending it up there? Go get up close and personal with either of these objects and take some pictures.
They're too high up. Okay, so Eratosthenes calculates the angle of the shadow and everything based, and so there's the path of the sun, so it matches the equator, so the circumference of 40,000 kilometers. So based on that geometry, they came up with a spherical model with the radius using pi to calculate then the angles and the distance to the sun. But somehow they got wildly different numbers, okay? So that's a huge problem for the heliocentric model. It wasn't until much later that they decided that the sun was about 93 million miles away, and the moon, based on the size difference that they calculated 400 times, they placed that at 238,000 miles away and stuck with that by committee. Okay, now that's not what we're doing when you take a flat, if you assume that it matches our observations of a flat plane, and you do the calculations with the shadow angles, you come up with something like 3,400 miles. Now, Dave, we have strapped cameras to weather balloons and send them up, but they don't go thousands of miles high. They don't. So what do you say?
If you get crafty with some robotics, which is a stretch given your complete lack of education,
I mean, come on, grow up. The truth of the matter is so opposite. I love
you
it.
could even scoop up a little sample. Maybe the moon is made of cheese after all. Can't you get even halfway there such that the sizes change?
You mean almost 2,000 miles with a weather balloon? No, we can't. No, it does not work that way. It's not how it works.
Reach for the sky, fellas. Number 9. Take some flights.
Come on.
Like any direct flight in the southern hemisphere. Whoops, shouldn't that be impossible? Better yet, fly between two cities 2 different ways. The shortest way on the globe and the shortest way on the flat Earth.
Well, yeah, we have, and the flight paths themselves indicate that what you showed isn't correct. That curve, that would be insane to do. What we're saying is that model is correct. Now, if we're saying that model is correct, then why would there be a curve that remains in the southern hemisphere throughout the duration of that long flight? It wouldn't. In fact, it would cross over into the northern hemisphere. And just like undersea cables, just like shipping routes, flight paths have a tendency to cross into the northern latitudes when the destination of origin and the point of origin and the destination are both in the southern latitudes. It crosses over into the northern hemisphere, especially when there's an emergency. It finds itself suddenly way far north. You'll see that inexplicably it crosses over into the northern latitudes.
Which one do you think will be faster? I'm just joking. I know that none of you will ever be employed long enough to afford a private jet.
Dave, employment isn't the way. Business ownership is the way to do it, but stepped away from it. Yeah, you have the closest point. You're going to cross into other lines of latitude even if your destination has the same latitude, because that's how the globe works, or so, at least in the northern hemisphere it does, verifiably with flight paths. Now that matches what we have because of the polar array of the azimuthal equidistant projection. That being said, it's the southern hemisphere where the deviation would be more apparent. And then once again, just like with everything else, observationally in the southern hemisphere at equal lines of latitude south, the number of data points drops dramatically. In fact, there are I think 0 flights crossing over Antarctica. Now that doesn't make sense. That would be if you're talking about the assumption or the presumption that flights always take the closest path, the shortest path between 2 points. Well, certainly they don't. Now, that being admitted from your side, I think you would have to, based on the facts, that point then becomes a little bit muddled. Even though it's muddled, what I said before about flight paths holds true and certainly explains our model better and presents more problems for the globe.
Yeah, you would notice that. If humanity is unfortunate enough that you've actually procreated,
that's really out of line. I'm sorry, but that's a disgusting thing to say. Because I disagree with you, you're going to now attack my offspring. I really am upset about that. That's no joke. You should apologize. Seriously. Your video should be reported for doing that.
send your kid up to the cockpit to meet the pilot and snap a pic of the wheel.
Well, my kid would know enough that they don't use steering wheels on jets. So maybe with your permission, it would be okay for me to procreate then, based on that alone.
What do you know? Straight as an arrow. And number 10, do anything legitimately scientific at all. Publish anything whatsoever about your model in anything reputable anywhere.
Oh, okay. So now you're talking about peer review. So you want us to do something that gets accepted by the same people who are tampering with and molesting the algorithm of the search engines, for example, or insulting us, telling us not to procreate. Our peers, okay, well, our peers do review. We have an open forum, and like the Globebusters show, it's not as rigid and formal. It's not as pretentious as what you're suggesting we do, but there's FE Core, there's a number of groups. There's many, many more. Now the so-called Flat Earth Society, that is not included because we agree that that's there as just something to make us look bad. And there are some people who are very sincere and legitimate in their sincerity who could make us look bad, except we don't rely on them for our own reputation. We are autodidactic. We do our own research. We are independent, and we don't rely on the approval or consensus of a group of people who have hidden political agendas and other agendas of profit and status and things like that based on politics and social fads and norms and all kinds of different problems like investments in the heliocentric model and benefiting from space programs, which get a lot of funding. I mean, $300 billion a year and rising to produce CGI and things like that we nobody gets real value from. I mean, maybe some entertainment value, but for that money, you could double up the entirety of the film and music industries. I think maybe more than double up, maybe triple or even more with that amount of money. It's so lopsided, but yet we're still here. Why do you think that is? It's because of the facts.
Invent any technology based on your model. Do anything at all that could be considered actual empirical science. Here's a hint. You may have to study some real science to do it, but then of course you would immediately learn that the Earth isn't flat, so it probably won't be of much use.
Oh my gosh. Because we never heard it before? I mean, come on.
So that's it for the 10 challenges. I use the word challenge facetiously since all of you will immediately recognize the futility and resort instead to calling me names in the comments section.
Even though I was called names and my offspring were brought into, I mean, come on. I don't feel the need to do that. But you said all, so you should apologize for that. The list of apologies, if we're talking about civilized discourse here, if we're talking about an intellectual discussion with mutual respect and polite discourse, I think that an apology would be in order. But that's neither here nor there. I'm so far beyond trying to win the approval of people who haven't investigated the topics. That seems to be the real problem if you want to know what I think. But I don't know. I think I've been written off already, so what I say apparently doesn't matter. But maybe some people listening care. If they do, maybe some subscribers should come over here and subscribe and possibly be a part of this journey of learning